I've added animation to my NPCs, and I want to use this animation to drive the position of the NPCs. So instead of driving the position directly using the NavMesh agent, I want to drive the position using the animation. I'll still use the NavMesh setup, but I will not be using the NavMesh agent directly. So here we'll have our floor, which will contain our NavMesh, and then I'll have some obstacles between my NPC and its target. This will be my NPC, and I want my character to move here. For this, the NavMesh will not actually update every single point every single frame. Instead, at the initial calculation, it will calculate a number of points, and the NPC will interpolate between these 2 points. So essentially, we calculate a number of points which are going to give us a path for the character to move along. This will be referred to as a path. It is, however, actually the points of this path which will drive the position of the NPC and not an actual path itself. So essentially what we're doing is generating this path. We then want to calculate the character's position based off this path. When the player deviates from this path too much, the path will generally be updated. So now, instead of using this to drive the NPC, I'm going to use this to drive the animation of the NPC. The animation will then update the position of the NavMesh agent, which should give me better animation for the character. There will, however, be a lot of drawbacks to this. So I'll have my character, and the character will have a forward direction, and this will define where the character is facing. We then have the destination for the character, and this is where we want the character to move towards. We'll be calculating values from these using the vector which is pointing along the direction to our target. Like with the player animation, I'm going to use this to get 2 values. I'll project the direction vector against the forward vector, and this will give us a vertical value. The direction vector will also be projected onto the right vector, and this will give us our horizontal value. So we can use this to get our character to traverse to its destination. However, from the character's current position, this will not give us a path directly towards the destination. Instead, at least for part of the way, the character will travel along a curve. This will of course depend on the number of animations which we have, and it can cause a huge amount of problems for us. But driving the character with the animation will give me much better animation quality if I can actually pull it off. So the biggest problems which we'll have are related to obstacles. So if we have an obstacle that is along the animated path, and we have the NavMesh offset from this obstacle, we'll see that not only does our animation penetrate the obstacle, it will also cause the character to leave the NavMesh. Leaving the NavMesh will not necessarily cause issues, as the animation should drive the character back onto the NavMesh, but there will be a lot of complications here. Walking through the wall is actually going to be the bigger issue, as this could potentially cause overlapping physics bodies, and this could cause major errors within the physics. So one of the main ways to compensate for this will be to make sure that the player never leaves the NavMesh. So we'll want to make sure that my player turns and adjusts along the NavMesh. But at the moment that is not particularly important, as I will first need to drive my NPC using the animation. And before I deal with that, I need to isolate the path from the NavMesh, and I want to be able to visualize where the character is actually moving. There are actually some dots methods available which we can use to perform this, and this is an experimental library, but I'm not going to do that at the moment. That's an experimental system, and I'm not worried about performance yet. I'm currently more interested in seeing whether I can make a good system using this approach. Essentially at the moment, this is still prototyping character movement and character combat. So now I'm going to work in Unity, and I'm going to calculate the path for my character to follow. I'll do this within the system script for the NPC. There are, however, some changes that I do want to make to the system in order to make it easier to work with. Currently I'm referencing my entity component buffer at the start of the system. I then have a for loop where I'm creating the NavMesh agent game objects for the system. Later in the script I have a second for loop, and this is generating my animator components. This setup is a bit redundant. There isn't any real logic occurring here, so we do not actually need to separate these. So I am going to perform all of this within a single for loop. So I'll copy everything from the second for loop into the first for loop, and I'll remove the second for loop. I will now need to update the variables for the for loop. The first of these will be animation, and the second will be for the NavMesh agent. I can then update my queries, and here I'm going to query the game object animation prefab. I'll also query the game object NavMesh prefab. I do not want to use the game object NPC anymore, as that's actually too vague and doesn't really specify which game object we are generating. I can then update the lines where I'm instantiating the prefabs. Here I'll be instantiating animation.prefab, and I'll instantiate the NavMesh agent prefab. The instantiation for the animation will be stored in the variable name animation prefab, and the instantiation for the NavMesh will be stored under the variable NavMesh prefab. I'll then update the line where I'm adding the game object transform component, and here I'll get the values from my animation prefab. The animation prefab will also be used when I'm getting the animator. The NavMesh agent should be referenced from the NavMesh agent prefab. So after I've got the components, I'll remove the original components so that they will not be added to the entity again. I do also want to make sure that these scripts are only running on the NPC now. So at the end of the query, I'm going to call the withAll method, and here I'll specify that we require the tag for the NPC. And I want to do this for every single one of my for loops. Because I'm separating the animation system from the NPC and the player, I want to do this for the player as well. So I want to make sure that every for loop for the player specifies that we need to have a player tag. Once again, this will be done with the withAll method, and the type will be tag player. So this will neaten up my player and NPC setup. I can now begin drawing out values to work with. For this, I'm going to use the debug library, and I'll use the drawLine method. I'll draw this from the center of the world, and I'll specify this with a new float3. I'll need to include the Unity mathematics library. I'll set this with an argument of 0. We'll then have our target value. I'll leave this blank for the moment as I have not specified this yet. I want to give this line a color, and this will be a cyan color. Cyan is a reasonably horrible color, but it is easy to see. I'm then going to draw a second version of this line. This line will be green. This line, however, is going to be set relative to my player, or in this case, I'm going to set this to be relative to my NavMesh agent. This will be specified with agent.navmeshagent.transform.position. Now I want to get the point along the path which the NavMesh agent is going to travel towards. I'll be getting this from the NavMesh agent. So this will be agent.navmeshagent. I'm then going to look for a property on my NavMesh agent, and this will be steering target. This is the point which the NavMesh agent is currently moving towards. This will give us a vector, and I'll store this in a float3. This variable will be called steering target. I can now use this value in my debug, so the second argument will be steering target for both of the debug lines. I can return to Unity, and I should now be able to use one of my target boxes to trigger my character. We should now have two forms of debug. The one will be showing where our player is moving to, and it will show this in world space. And the second will be the direction from the player to the current point. So the green line here will represent the direction which we need for the animation, and I now have visualizations for what I need to do.